Working with stock model operations. My name is Mariana Lendl, and I am a trainer and book developer at In-House Solutions. In this video, I'm going to explain what stock model toolpath operations are and how they can be created. In the first example, you will learn how to use a stock model to generate REST machining toolpaths. You will also learn how to use the stock model to check the toolpaths in Verify. The second example demonstrates how to export a stock model as an STL file and then merge it back into a different machine group in the same file. This example can be very useful when programming a part that has both turning and milling toolpaths. Stock models are created in the Toolpaths Manager in the same way as you create toolpath operations. Being a toolpath operation, you can display the stock model or hide it using the same toggle toolpath display on selected operations icon. Most commonly, to define the stock model, you first set the original stock and then select the operations from which you are generating the stock model. Another option is to create a stock model with no source operations. In this case, you can select as stock surfaces, solids, Mastercam mesh entities, or an STL file. We'll start by machining a part from a casting stock. We will set the stock model from an STL file and then use it to define the stock in the REST machining toolpath. Then, you will define a stock model after roughing toolpath that can be used in the Verify simulator to check the finished toolpaths. In the last example, you are going to see how to save a stock model as an STL file in a lathe machine group and then import it back in a mill machine group for a part that requires both lathe and mill toolpaths. Using a stock model to machine a casting part. We will define the stock model from an STL file that contains the casting part. Then you will use the same stock model in a REST roughing toolpath to instruct the software to remove only the stock material from the casting part. Only the REST material options in the toolpath allow you to machine the part from the real stock. They ensure that you are machining the part without the extra air moves that are generated from a box-shaped stock. Note that even if you set your stock in the stock setup as a casting stock, the toolpaths are going to be generated from a box shape unless you are using the REST material options. In these two graphics, you can notice how the part was machined with REST material options enabled and without the REST material options. We are using the same toolpath in both examples. On the right side image, you can see how the toolpath is generated from a box shape, while on the left side image, it's taking into account our real stock. We will start by setting the stock in the stock setup in the machine group properties. You'll first need to enable file and to find the STL file that contains the casting part model. To display it, enable display and then OK. You will see the stock with red color lines that shows you the STL file that was brought in Mastercam as a mesh. We'll turn it off from the display to make sure that we can select our surfaces to generate the toolpaths. First, we are going to create the stock model. In the stock definition, enter a name. We'll enter casting stock. Enable file and then select the STL file again. Once you open the STL file, you can just select the OK button to generate the stock model. It will take a couple of seconds. Once the stock model is generated, you can see in the graphic windows how it's going to look. Remember, this is treated as a toolpath. From the Toolpaths Manager, you can use the toggle display on selected operations to remove it from the screen. You can also press Alt-T. This will bring it back on the screen, Alt-T again to hide it. Note that our part origin is set up at the center of the hole. We are going to rough out the part using the Surface High-Speed Toolpath OptiRough. Surface High-Speed Dynamic OptiRough works well on parts with combined bosses and cavities. The toolpath supports cutters capable of machining very large depth of cut. After stepping down and removing the maximum amount of material, the tool will step up along the part, removing the scallops left by the bigger cut. I'm going to start the operation. In the model geometry, we need to select the surfaces that are going to be machined. We are also going to leave some stock for a finish operation on both walls and floors. Select the toolpath control and select a boundary. The boundary should have been created prior to this operation. We are going to machine the part from the outside, and we are going to compensate the tool to the outside of the boundary, giving an extra offset distance of 200 thou. This ensures that the entire part will be completely machined. Select the tool page and make sure that you are selecting the tool that you want to use to rough out this part. Select the stock and enable rest material options. We are going to enable one other operation and make sure that the stock model is selected. This tells Mastercam to calculate the rough passes based on the stock model, preventing the tool from cutting in the air. We will also make sure that Use as Computed is selected. This will instruct the software to make no adjustments to the stock model when it calculates the remaining material. In the cut parameters, I'm going to go with 200% of the tool as the step down, and I'm going to enable step up to ensure that the shape is going to be cleaned up. In the stip shallow, I'm going to enable use depth cuts and detect limits. In our example, I want to limit the cut and not cut below Z0. Once the toolpath is generated, we are going to use Verify to simulate it. The casting part stock will appear in Verify. Run the simulation to see how the part will look after roughing. In the next step, we are going to learn how to use the stock model in Verify Simulator. You will create a stock model after the OptiRough toolpath and use it as a stock in Verify to simulate the finished toolpaths. This option allows you to save time when checking toolpaths in Verify. You won't need to wait until the roughing operation is simulated. Back in Mastercam, select the stock model. Name it Stock After Roughing. As the initial stock, click on the stock setup. This will automatically select the casting part STL file that we used in the stock setup. And then select the source operations. In the source operation, make sure that Surface High-Speed Dynamic OptiRest is selected. Choose the OK button to generate the stock model. You can visualize it in the graphic window. Again, remember to remove the display of the stock model. You can use that toggle display on selected operations icon. Next, we are going to finish the part using Surface High-Speed Hybrid, which, similar with the High-Speed Dynamic OptiRest, works for parts that have combined shallow areas with vertical walls. In the 3D group, select the Hybrid. Select the entities that you want to machine. Make sure that there is no stock left. In the toolpath control, select again the boundary and enable the same settings as we did for the dynamic OptiRough. In the tool page, make sure that you select the tool that you want to use for finish. Select the cut parameters. Make sure that you make the changes according to how you want this toolpath to machine the part. In the step shallow, use set depths and click on the detect limits. Again, we want the maximum depth to be 0. OK, and let the system to generate the toolpath. As you can see, multiple stock models can be generated in the same part. To ensure that Verify is going to use the last stock model that you created, you have to select the simulator options and enable stock model. From the list, select stock after roughing, and then OK. Next, you only need to select the Surface High-Speed Hybrid and verify selected operations. The stock model that you created after the roughing operation will be brought in. Run the simulation. The part after the finished toolpath should look as shown. You can minimize simulator. This concludes our first example. In the next example, you are going to see how to use a stock model in a part that requires both turning toolpaths and mill toolpaths. You will learn how to create a stock model in the lathe machine group and then use it in a mill machine group. The following steps will be required. You need to define a stock model after all the lathe toolpaths. Export the stock model as an STL file. Then set the current level and set the plane. Merge the STL file stock model using the current attributes. Create a new stock model in the mill machine group. And create the mill toolpaths and verify them using the new stock model. Let's see these steps in Mastercam. In this last example, as you can see, the part requires both turning and milling operations. All the lathe operations are already created. To machine the part on the lathe, we use roughing, finishing, drilling, and grooving toolpaths. We also need to use the lathe stock flip path, as this part requires operation from both sides. I'm going to select all the lathe toolpaths and run verify. We can check the part by running the simulator. The part should look as shown after all the lathe toolpaths were done. Back to Mastercam, we are going to create a stock model. We can name it stock after turning. The initial stock shape is going to be selected from the stock setup. And in the source operations, you can just select all the operations, all the lathe operations, and then OK to generate the stock. Remember that the stock model is still a toolpath. To remove it from the screen, you can use the same toggle display on selected operations. Before that, we should export the stock as an STL file. Find the place where you want to save the stock. Once you saved the STL file, the next step will be to bring it back into the same file using merge command. Before we do that, we need to create another level using levels manager. I'm just going to enter number 20 and I'm going to name it stock after turning. In this level, we are going to bring back the STL file. Use File and Merge and find the STL file and open. We will enable Use Current Attributes in order for the system to bring the stock on level 20. Then, if you just look on the screen, you can see the stock is going to be brought back in the same orientation as it was saved as an STL file. We need to rotate the part to create all the milling operations required on a vertical machining center. You can use Planes Manager, and in the Planes Manager, we can set lathe Z equal word Z as our work coordinate system, construction plane, and tool plane. You can see how the part is going to be rotated. Select the OK button to exit merge pattern. And from the toolpaths manager, you can select toggle display on selected operations to remove the stock model that you create after turning. Next thing to do will be to prepare our part for milling operation. From Levels Manager, make your main level level 1 and make invisible all the other levels. In the Toolpath Manager, select all and get rid of any toolpath display. To position the part in the proper orientation for milling toolpaths, we are going to use Transform Translate to Plane. Make sure that you are in Transform ribbon, Translate to Plane, select the geometry and selection. We are going to keep the original geometry as it is, so copy should be selected. In the source plane, we are going to select the left side, and as destination plane, top. You can see the preview of the translate command result. OK for now. I'm going to move the result geometry, so I'm going to select all result entities, right mouse click, change level, move, using a different level, level 30 for example. And then back to levels, I'm going to make level 30 the only one visible. Before we can start any milling toolpaths, we need to make sure that the origin is going to be set up at the top of the part in the center of this hole. From the same transform ribbon, we are going to use move to origin and select the point where we want the origin to be located. I want to get rid of the stock and chuck display from the screen, so I'm going to go back to the stock setup and disable display options. Also, you can observe that we are in the wrong plane. I'm going to go back to the planes and make our top plane, WCS, construction plane, and tool plane. Now we are ready to do all the milling toolpaths. Select machine and select the mill default. Before we start our toolpaths for milling, we'll set up the stock model. In levels, we are going to make level 20 the main level and the only one visible. And in the stock model, we are going to enter a name, stock for milling, for example, and we are going to enable model and select our stock. The stock model will be generated very quick. We are going back to levels, make main level level 30, making visible level 20. In the toolpaths manager, I'm going to remove the display of the stock. From this point, you can start to create all the milling operations required by this part. You're going to need to do some drilling operation and a couple of contour operations too. Once you create all the milling toolpaths required to machine the part, you can use the stock model that you exported from the lathe to verify your milling operations. Make sure that in the simulator options, you select stock model and select the one that we need to use to check the milling operations. Verify. The stock model will appear in Verify, and you can run the simulator to check all the milling operations. This concludes our second example.